Demystifying Loads in Structural Analysis, a comprehensive guide. Introduction. Hey there, fellow engineering enthusiasts. Welcome back to my vlog. Today, we're diving deep into the world of structural analysis, specifically focusing on one of its fundamental aspects, loads. Whether you're a student learning the ropes or a seasoned engineer looking to refresh your knowledge, this vlog is for you. Define load. Let's start with the basics. What exactly is a load in structural analysis? Simply put, a load is any external force applied to a structure, which can include buildings, bridges, or even everyday objects. Understanding loads is crucial because they are the driving forces behind how structures behave. Types of loads. There are several types of loads you need to be aware of. 1. Dead loads. These are the static loads caused by the weight of the structure itself and any permanently attached elements, like walls and floors. 2. Live loads. These are dynamic loads that result from the presence of people, furniture, vehicles, or other transient factors within or on the structure. 3. Wind loads. Wind can exert significant forces on structures, especially tall buildings or bridges. Engineers need to account for these loads to ensure stability. For snow loads. In regions with cold climates, the weight of accumulated snow on a structure can be substantial and must be considered. 5. Seismic loads. In earthquake-prone areas, seismic loads are essential. These loads result from ground motion or an earthquake and can be highly destructive if not properly accounted for. 6. Temperature loads. Extreme temperature changes can cause a structure to expand or contract, leading to thermal stresses. 7. Point loads and distributed loads. These are concentrated forces applied at specific points or distributed across an area, respectively. Load calculations. Once you've identified the types of loads your structure will encounter, you need to calculate their magnitude and direction. Engineers use mathematical models and analysis techniques to determine how these loads will affect the structure's integrity and safety. This involves understanding concepts like equilibrium, stress, and strain. Load distribution. It's important to remember that loads are rarely uniform. They can vary in intensity, direction, and location. Engineers use load distribution analysis to ensure that the structure can handle these variations without failure. Factors like beam deflection and shear forces become crucial here. Load combinations. In practice, structures often experience multiple loads simultaneously. Engineers use load combinations to account for these scenarios. Codes and standards, such as those provided by organizations like the American Society of Civil Engineers (ASCE) or Eurocodes, offer guidelines on how to combine loads effectively. Importance of safety factors. To ensure the safety of a structure and its occupants, engineers apply safety factors to their load calculations. These factors account for uncertainties in load magnitude and material properties, as well as the consequences of failure. Conclusion. In conclusion, loads are the driving forces that structural engineers must analyze and account for when designing safe and functional structures. Understanding the types of loads, their calculations, distribution, combinations, and the importance of safety factors are all essential aspects of structural analysis. I hope this vlog has shed some light on the fascinating world of loads in structural analysis. Remember, engineering is all about balancing form and function to create structures that stand the test of time. If you have any questions or want to dive deeper into any aspect of this topic, feel free to leave a comment below. Thanks for tuning in, and until next time, stay curious.